Bill, the renowned scientist, has been captivating us for decades with groundbreaking discoveries and unraveling their complexities. His enthusiasm for space exploration has sparked our curiosity about the unknown, as he introduces us to the immense expanse of the cosmos that envelopes us and extends endlessly above. Bill now breaks his silence regarding the most recent images from the James Webb Space Telescope, offering us a peek into a universe over 13 billion years old, drastically reshaping our understanding of the universe and altering our view on existence itself. This telescope is uncovering new details about faraway planets, galaxies, and much more. It represents a monumental leap in science and stands as a fitting successor to the Hubble Space Telescope. But what exactly makes the Webb's images so exceptional, defying our expectations and current theories, and what insights does Bill have to share about them? The creation of this project is the result of years of diligent work from NASA scientists and engineers, with its launch taking place on Christmas Day in 2021. The various stages of the telescope's deployment went off without a hitch over the following months. By June 2022, scientists began to observe Bill Nye's reaction to the image of thousands of newly discovered galaxies, some of which are older and farther away than previously known. Some of these galaxies could have formed up to 150 million years before Hubble's earliest discoveries. Additionally, the telescope has the ability to capture enough light from celestial objects like exoplanets and stars, revealing details about their composition and their paths through space. According to Bill, this data is already offering profound insights into the atmospheric makeup of planets located light years from Earth, allowing scientists to make informed guesses about their ability to sustain life as we know it. One of the Hubble Space Telescope's most iconic images has long been the Pillars of Creation in the Eagle Nebula. This structure was visible through Hubble, which primarily detects visible light, but the processes occurring within it were not fully understood. The Webb Telescope, with its infrared capabilities, has provided a deeper view of the nebula, revealing numerous protostars. These appear as clusters of gas and dust, each several times the size of our solar system, marked by small red dots against the backdrop of the pillars. Bill notes that these stars aren't yet burning hydrogen. As material accumulates toward the center of these forming stars, it becomes increasingly dense, eventually triggering hydrogen burning, which causes a dramatic rise in temperature to around 2 million degrees Celsius. Two distinct colors in the infrared image reflect wavelengths invisible to the human eye. The only visible parts of the image appear blue, with hues intensifying the red radiation as the protostars emit radiation at a wavelength 6 times longer than what we can see. Bill suggests that this image not only highlights the Webb Telescope's infrared capabilities, but also sheds light on the process of star formation, similar to that of our own Sunday. Exoplanets were first discovered in the 1990s. And today over 3,000 planets are confirmed to orbit distant stars. However, only a fraction of them have been directly imaged. Most exoplanets are too far away to be seen directly, only detectable when their star's light is dimmed by their presence. The first direct image of an exoplanet was captured last year. This planet, named HIP 65426b, was identified in 2017. Scientists use coronagraphs on telescopes to block out the light from the central star, combined with 2 of Webb's cameras and a set of filters to observe the planet. This exoplanet is notable for its outstanding infrared sensitivity and its great distance from its star, 100 times the distance between the Earth and the Sun. It's a massive gas giant, nearly 12 times the size of Jupiter. The Ghost Galaxy, though faint in the sky, can be captured with infrared cameras. The spiral shape of the galaxy, with its stars radiating from the center, is visible in optical images, often referred to as M74. However, the latest Webb Telescope images show additional features, like filaments of heated dust and gas emanating from a bright core captured in striking electric blue. This new view will help illuminate areas where stars are forming within the galaxy's spiral arms. Combining Hubble and Webb Space Telescope images, researchers have created a composite image that merges optical and infrared views of the galaxy. This composite was produced by researchers from the European Space Agency, ESA, as part of the FANGS project, which observes 19 nearby galaxies using Webb, Hubble, and various ground-based telescopes in infrared wavelengths. Thanks to Webb's precise observations, astronomers can now identify star formation areas in galaxies, accurately measure the ages and masses of star clusters, and study the properties of minute dust particles drifting through interstellar space. In an image of the distant star Wolf-Rayet 140, taken last July, a recognizable diffraction pattern was seen. However, the star is also surrounded by unusual wavy concentrated rings with a square-like appearance. These rings, unlike the typical diffraction pattern, are characteristic of massive stars known as Wolf-Rayet stars, which are nearing the end of their lives and have already expelled large amounts of hydrogen. The interaction between WR140 and a smaller companion star gives rise to these distinctive ring shapes. The Webb Telescope is designed to observe the most distant galaxies in the universe, and in mid-December of last year, researchers reported the discovery of 4 of the oldest known galaxies. These galaxies, seen for the first time by Webb, date back 13.4 billion years, when the universe was only 350 million years old, or about 2% of its current age. These 4 galaxies were once thought to be extremely old, similar to many other galaxies Webb has discovered. Researchers used the James Webb Telescope's capabilities to measure their distance, determining their age through redshift, which measures the stretching of light wavelengths caused by the universe's expansion. The largest redshift ever recorded was 13.2, and these newly discovered galaxies exceed even the predictions of astronomers before Webb's launch. For the first time, we can pinpoint galaxies from this early era and spectrographically verify their immense distance. Meanwhile, Webb has also studied a planet in the Virgo constellation named WASP-39b. This planet is located about 700 light-years away, orbiting its star 8 times closer than Mercury is to the Sun. A gas giant similar in size to Saturn, 39b has an atmosphere thick with sulfur and silicates, including sulfur dioxide. Using Webb spectrographs, scientists were able to detect carbon dioxide in its atmosphere, further enhancing our understanding of distant exoplanets. The launch of the James Webb Space Telescope marks a new era in space exploration, where the boundaries of our knowledge are constantly being expanded. Bill, along with countless scientists and engineers, continues to marvel at the way this cutting-edge technology has transformed our understanding of the universe. The Webb Telescope isn't just a tool for observing distant stars and galaxies. It's a monumental leap forward in the pursuit of answering some of humanity's most profound questions about the cosmos, life, and the nature of existence itself. What could this mean for humanity? What makes this telescope truly special is its ability to peer deeper into space and time than any other observatory before it. While Hubble has provided us with breathtaking images of galaxies, nebulae, and distant stars, the Webb Telescope brings a level of detail and clarity that was previously unimaginable. With its advanced infrared capabilities, Webb can capture wavelengths of light that Hubble simply cannot, allowing scientists to observe phenomena that are hidden from our eyes. One of the most remarkable features of Webb's capabilities is its ability to detect the faintest traces of light emitted by distant objects. This allows researchers to look back in time, as Webb's observations are able to capture light from galaxies formed over 13 billion years ago, shortly after the Big Bang. By observing these early galaxies, scientists are gaining insight into the formation of the universe and the conditions that led to the birth of stars and planets. Bill points out that the sheer scale of the discoveries Webb is making is truly mind-boggling. The telescope's ability to reveal new galaxies, exoplanets, and star-forming regions provides us with an unprecedented view of the universe. Each new image captured by Webb not only provides us with more data, but also raises new questions that will fuel the pursuit of knowledge for years to come. In addition to its exploration of distant galaxies, Webb is also providing us with a deeper understanding of our own solar system. The telescope's observations of planets, moons, and other objects in our cosmic neighborhood are uncovering new details about their atmospheres, compositions, and potential for supporting life. As Bill explains, the ability to analyze the atmospheres of exoplanets in such detail is one of Webb's most exciting features. By studying the chemical makeup of these distant worlds, scientists can begin to assess their potential to harbor life, whether in the form of microbial organisms or more complex life forms. As the telescope continues to gather data, it is likely that many more groundbreaking discoveries will be made. Bill emphasizes that we are only beginning to scratch the surface of what Webb can teach us. From studying the formation of the first galaxies to uncovering the mysteries of distant exoplanets, the possibilities are virtually limitless. Moreover, Webb's ability to study the oldest and most distant galaxies in the universe offers us a unique opportunity to understand the early stages of cosmic evolution. By observing galaxies that formed just a few 100 million years after the Big Bang, scientists can learn more about the processes that led to the creation of stars, galaxies, and the elements necessary for life. Bill also highlights the importance of collaboration in the success of the Webb mission. The telescope is the result of years of work by scientists, engineers, and space agencies from around the world. The cooperation between NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA, has been crucial in bringing this extraordinary project to fruition. Bill believes that the success of Webb is a testament to the power of international collaboration in advancing scientific knowledge. As the data continues to pour in, Bill encourages everyone to stay tuned and follow the incredible discoveries that are unfolding before our eyes. With each new observation, we are getting closer to answering some of the most profound questions in science. What is the true nature of dark matter? How did the universe begin? And what is its ultimate fate? And perhaps most importantly, are we alone in the cosmos? These questions, which have long fascinated humanity, are now within our reach thanks to the James Webb Space Telescope. As Bill wraps up, he invites us all to share in the excitement of this new chapter in space exploration by continuing to support and invest in scientific endeavors like Webb. We are not only expanding our knowledge of the universe, but also paving the way for future generations to build upon these discoveries. So, as we eagerly await the next set of images and findings from the Webb Telescope, Bill reminds us that we are living in a truly extraordinary time. The mysteries of the universe are being unveiled before our eyes, and the possibilities for discovery are endless. Be sure to keep up with the latest news and updates, and as always, Bill encourages us to stay curious, stay inspired, and continue to explore the wonders of the universe together. The journey is just beginning, and there is so much more to uncover. As we look toward the future, the James Webb Space Telescope will undoubtedly continue to amaze us with its astonishing capabilities. Every new discovery it makes brings us closer to understanding the very fabric of the universe. Bill, a passionate advocate for science and exploration, reminds us that space exploration is not just about uncovering new knowledge. It's about expanding the horizons of human understanding and pushing the limits of what we know. Webb's extraordinary images and data will play a crucial role in answering fundamental questions about our existence, our place in the cosmos, and the potential for life beyond Earth. Webb's ability to study distant galaxies, exoplanets, and other celestial phenomena has opened up new frontiers of research that will keep scientists busy for decades to come. Bill notes that the Webb Telescope is not just a tool for astronomers. It's a window into the past, allowing us to observe the universe as it was billions of years ago. This time-traveling capability gives us a glimpse of the cosmos at a stage when the first stars and galaxies were forming. By studying these ancient cosmic objects, scientists are learning how the universe evolved and the conditions that led to the creation of stars, planets, and ultimately life. One of the most exciting aspects of Webb's mission is its potential to find planets that could harbor life. Bill highlights how the telescope's ability to study the atmospheres of exoplanets in such detail is a major breakthrough.